Let's practice with FOIL here. We want to be very careful. I think it's very easy to go a little too fast and lose details. So when you FOIL, binomial times a binomial, when we multiply our firsts, this is going to be one of the ones you want to go slow on. When I multiply root 3x times root 3x, what might that look like? Square root of 9x squared. I agree. Good. Guys have any questions on that? It's a good answer for sure. Okay. So that's your first. How about your outers? What happens when you multiply those?
2 root 3x.
That's right. We want to be really careful with these because some people I think would be tempted to write root 6x. We got to keep in mind that the 2 is not a radicand, but the root 3x does have a radicand, so we can't multiply those like they are both radicands. 2 root 3x would be the right answer there. What happens when you multiply your inners on the FOIL?
Negative 5 3x.
Good. Negative 5 square root of 3x. And then finally when you sneak in your lasts, what do you get?
Negative 10.
That's the easiest one, right? Kind of nice to finish with that. Okay, so there is some simplifying that can be done. First of all, do you see any like radicals? Which ones are like? Yeah, the middles happen to be like radicals. And so those two can be combined. So if I were to combine those, what is 2 root 3x minus 5 root 3x? That is right. Negative 3 root 3x. Still have that minus 10 hanging out there. Does anybody know how to simplify root 9x squared? What would that break down to be? Just a 3x. Good. Okay. So we're going to do one last check and make sure that we haven't left anything unsimplified. Do you see anything else that we could simplify or perhaps some like terms that we could combine? Or are we done? We're done. We are done. Yep. Okay. Any questions there? Amelia?
Actually, no, never mind. I solved it. Never mind.
Okay. Okay. Let's take a look at number 11. I want to start number 11 with you, and then I'll let you finish it. There's going to be a severe temptation with number 11. Are you all watching?
Yes.
Please look at the screen, including, everybody. There's going to be a temptation. What I'm about to do is wrong. There's going to be a temptation to do this. Are you all watching and paying close attention? What I'm about to do is wrong. I've seen people do this before. You see why somebody might be tempted to do that? Does anybody know what is the one symbol that makes that wrong?
The parentheses.
Okay, yeah, parentheses, yes, but it's something else.
The subtraction sign.
Yeah, the subtraction. If subtraction or addition in there, that means you can't do that. So, whenever you've got a binomial being squared, the terminology that we used in the past was expand, then FOIL. So we'd rewrite this, to do this correctly, we'd rewrite it as root 23 minus root x, in parentheses, times root 23 minus root x. Once you've expanded it, now it's time to FOIL. So I'm going to let you guys try that. That's pretty similar to number 10 once we get to that stage. So give it a shot. I think there's some things worth talking about. So I think just about everybody that I saw did root 23 times root 23, and they got square root, I think it was 529. Square root of 529. Okay, so that was good. And then you multiply your outers. And here is where I do have a comment for you. I want you guys to look really carefully at this. This is pretty important. So minus square root of 23x. I saw stuff like that a lot. And so I would say that that's just a tad ambiguous, like it's not clear what you're trying to say. The question I'd have for you if I saw something like that would be, is the x in the radical? Like, is the x part of the radicand or is it not? What do you think? Should the x be part of the radicand or should it be outside? It should be part of it. And so here is a way to indicate that. Number one, make the radical long enough. Do you see how I just extended it out a little bit? And then you can also do this. You can also cap it a little bit. It's considered standard notation. Essentially, it's saying, hey, the radicand is contained to the left of that little tail hanging down. You don't have to do that, but I think that's good practice. And then you multiply your inners, and you get the same thing. Minus square root of 23x. And then you multiply your lasts, and you get plus the square root of x squared. So far, so good? Okay, so square root of 529. Maybe you did that on your calculator. Who knows? It's okay either way. It's 23. 23 times 23 is 529. And then when you combine your middles, you get minus 2 root 23x. There's two of them, right? They're both negative 1. So minus 1 is negative 2. And then finally, what's the square root of x squared?
X.
So plus x would finish this one off. So on this one here and this one here, the coefficients are technically minus 1s. So if you have a negative 1 plus another negative 1, you get negative 2. 23. Yeah, 23. We good? Okay, let's tackle our last topic. Oops. And it is right here. So this skill is an important skill, especially when it comes, ladies, especially when it comes to trigonometry. Christiana, let's put the cards away. Don't jeopardize your chance of doing well in math.
Are you playing poker?
No, they're studying some vocab words of some kind. Jeopardizing their math grade. Anyway, so this will become particularly, yeah, that's fine. Particularly useful when you study trigonometry, geometry, things of that nature. And then moving forward, you'll do different things with this. This is called rationalizing the denominator. I think you'll find this to be pretty straightforward. Completing this process of rationalizing the denominator will remove any radicals, any roots, any radicals from the denominator. So, I mean, there's a number of philosophies on this, why it's important, is it important? I believe that it is important for you to be able to see things you need to see. But you notice number 12. You see how, as it stands, it's 4 divided by the square root of 5? So 4 divided by the square root of 5. Way that you can think about this, sorry?
The big one.
We're going to use a big one, right, or a smart one. So we don't want to leave radicals in the denominator. I've heard lots of illustrations about this. Like radical kind of sounds like a rat. Nobody wants a rat in the basement. You want to get them out in the open so you can get them. I mean, there's all kinds of little illustrations. But the bottom line is this. Here is how we remove the radicals from the denominator. In number 12, what we would say is, since there's a square root of 5 in the denominator, we are going to multiply the top and the bottom by the square root of 5. This is how you rationalize a single term fraction. So square root of 5 over the square root of 5, this is what Christiana, I think, was referring to. What is something divided by itself? 1. And so when you think about what I've done here, I have multiplied my original fraction by a 1. It's a really smart one, or it's a big one, or whatever you want to call it. But all I've done is multiply by 1, which doesn't really change the value of anything. It simply changes the form. So let's go ahead and write out what this equals. What is 4 times the square root of 5? Yep, those are not radicals. Just one of them is. So 4 square root of 5. But in the denominator, you do have 2 radicals multiplied together. What is root 5 times root 5?
Square root of 25.
Square root of 25. And the square root of 25, as you mentioned, Rocky, is 5. So as I mentioned, at the end of this process, we should have all the radicals removed from the denominator. And you can see there's a radical in the numerator. That's okay. All the radicals in the denominator are removed. One of the reasons we do this is so we can recognize quickly various forms of the same number, really what it comes down to. Let's take a look at number 13 and we'll be done. 13 says rationalize root 17 fifths. So before we do too much with any rationalizing, let's remember that the square root of a fraction can be simplified, can it? How could we rewrite root 17 fifths?
Radical 17 over radical.
There we go. Yeah, you guys got it. So square root of 17, let's try that again. Square root of 17 over the square root of 5. So now you can more clearly see the radical in the denominator. So to remove that radical from the denominator, we need to multiply by what?
Reciprocal.
Not a reciprocal.
Radical 5 over radical 5.
Yep, specifically by 1. If we multiply by the reciprocal, we are not multiplying by 1, and we are therefore changing the value of the fraction, which we have no good reason to do.
But
So
aren't they both radicals?
yeah, but one of them is root 17.
Does it?
They go with the smaller one?
You go with the one on the bottom.
Radical.
You always, Hunter, your question is a good one. You always multiply by whatever the radical in the denominator is.
Okay.
Yep. Okay, so when we multiply, root 17 times root 5 is what?
Root 90.
Nope,
101.
85.
Close enough.
No, not close enough. What about the square root of 5 times the square root of 5? Just like before, square root of 25. So that gives us square root of 85 over 5. But can the square root of 85 be simplified any further?
No.
No, you can't.
What are the prime factors of 85?
5 and 17.
17 and 5, yeah. There's no pairs, and so we're left with that. Okay, so that's it. At this point in the game, you guys are all well equipped to finish your homeworks 8.3 and 8.4.